Hi, Algebra 1 students. This is Miss Graham, and today we are going to be looking at lesson 25.2 and lesson 25.3. So go ahead and pull out page 376. Our first learning targets that we will focus on are multiplying binomials, just like we have been doing the past couple of days. And then the next one is going to be finding special products of binomials. So let's look at number 1 below. So we can see we have 4 different problems where we're going to determine each product, and we're going to see if we can notice a pattern as we go through this, and we're going to describe it in part B. So let's go ahead. I want you to pause the video right now, and I want you to find the product of all 4 of those, and you can choose to do this either through the distributive property or using that kind of box organizer to multiply the binomials. Pause the video and press play whenever you're ready. All right, you can go ahead and see that for part A and B, I actually use the distributive property, and then for C and D, I use the box method, so you can kind of get a visual of what this looks like from all of those. So as you can see, when we found out the product, the final result, as I have highlighted kind of in this purple color, is we ended up with 2 terms. We ended up with 2 terms for all of them. And in fact, what we noticed was kind of our middle x terms, they canceled each other out. So we can see that, when the product's multiplied, we see that those linear terms will add to 0. And the answer will be in the form of our variable term squared minus whatever that number is squared. So let's go ahead and answer this below with kind of what we talked about. So we can see that we end up with 2 terms, and our x term is canceled out. Nice. So that's something we can kind of use to predict when we have these problems, where if you didn't notice, if we look at our parentheses, the only difference between these 2 is our addition and subtraction sign. The same goes for part B. The only difference between these 2 binomials being multiplied is the addition and subtraction sign. So that's a pattern that we can notice. If we have the same binomial multiplied times itself, but the only difference is the addition and subtraction signs, then we know we're going to be left with just 2 terms where our middle x term will be canceled out. So that's a pretty cool pattern that we can start to notice here. So let's look below at number 3, and it says the product of binomials of the form a plus b times a minus b, it has a special pattern called the difference of 2 squares. So we can use the patterns that we found in numbers 1 and 2 kind of to explain how to find the product of a plus b times a minus b. So what's really going to happen is we're going to end up having kind of our first term of a will be squared, and we'll be subtracting whatever b is squared. If you look back at our original problems above, you can kind of see, hey, all of them are separated by a difference sign. So again, if we look in the margin, we can see this pattern is known as the difference of 2 squares. So we can still apply it the same way with the distribution property or using our box method, but it's a pattern where we notice the middle term cancels out. Now we're going to learn another special example, so let's go ahead and flip to the next page. Let's go ahead and look at number 4 at the top. So as you can see, this looks a little bit different. We have a whole entire binomial, and we have a squared symbol. So this is going to kind of require our knowledge from previously in our unit to be applied here. A lot of us would first start off going and distributing. We'd think, oh, let's make sure we give the squared sign to each of these pieces. But that is wrong. All right, so we're going to go over to the margin, and I'm going to show you what we're not going to do, okay? So I'm going to take kind of our first example. We're going to look at part A. We're going to take this guy to the margin for just a second. So let's look at part A in the margin over here. So we're going to write down x plus 1 squared. And I'm going to tell you that that is not equal to x squared plus 1 squared. This is a huge piece to kind of keep in mind. We cannot just distribute that squared symbol. Instead, that squared symbol means, remember, to write something down twice. We have 2 of those. So rather, x plus 1, that whole quantity squared, is actually equal to x plus 1 times x plus 1. So it's the same exact binomial times itself. So now we can actually go ahead and apply either the distributive property or the box method to find our result for both. I'm going to go ahead and show the distributive property and the box method. So you go ahead, do a little bit of the work, pause the video, and come back to check your answer for what you should get. All right, so let's go ahead and check. You should end up getting x squared plus 2x plus 1. So what you see, again, is a similar pattern to what we've done before, where we end up adding kind of our middle terms together. So you can see I got it through the distributive property as well as that box method. So that's actually what we're going to have to be required to do here if we're looking at all of these products. So you can see we did part A in the margin. So here's what I'm going to ask you to try to do. I want you to try on your own to go ahead and complete part D and part E. So I want you to go ahead. You don't have to use both the distributive property and the box method. You can use whatever method you would like to do, but I want you to go ahead and now try doing both of those problems. Pause the video and press play when you're ready to check them. All right, so for those answers, for part D, we should have gotten 4y squared plus 12y plus 9. And for part E, we should have gotten x squared minus 10x plus 25. We're going to go ahead and skip over number 5 and jump to number 6. So going to number 6, we can see that this is a special name. It's the square of a binomial, where we have a plus b whole quantity squared, or we could have a minus b whole quantity squared. We have a special pattern where we have to recognize we're not just distributing this exponent. No. We talked about that. This means we write out our binomial twice. So again, it's the square of a binomial, another way that we can multiply different products of binomials. All right, we're going to head to the next page and do a little quick review. So go ahead, let's zoom on in. All right, we're going to go ahead and do a little bit of practice. Let's zoom in. Let's look at numbers. Here's what I think we should do. I think we should look at number 12 and 13. So go ahead and look at 12 and 13. And I want you to go ahead and try to use kind of our 2 new special products. We're still using, distributive property or the box method, but these are different types of problems that we're looking at from, 25-1. So pause the video right here, try these problems kind of mixed together and see what you get as a resulting answer. All right, for number 12, we should get y squared minus 20y, y squared minus 100. I realized, wait a minute, there's not going to be a middle term, right? Because we have just about the same binomial, but the signs are different, so we know the middle term is going to cancel out. Now looking at 13, that's where we will have the middle term because remember, we're saying y minus 10 times y minus 10. So our result should be y squared minus 20y plus 100. So now we're going to go ahead and turn to lesson 25.3. Let's start off looking at our learning targets here. we're going to use a graphic organizer. So we're going to use that box method to multiply polynomials. And we're also going to use the distributive property to multiply polynomials. So really the main difference here is we're not just doing two terms anymore. It's not just binomials. We might use monomials. We might use trinomials. So we're taking it a step up from what we learned in our previous lesson. So let's look at the problem below. It says a graphic organizer, what we call the box method, can be used to multiply polynomials that have more than two terms, such as binomial times a trinomial. The graphic organizer at the right is used to multiply x plus 2 times x squared plus 2x plus 3. So I'm going to use a little bit of color to kind of help us out. So I'm going to show you where I have the x plus 2. I have that kind of up at the top here, sectioned off, so that should look pretty familiar. And then for the x squared plus 2x plus 3, I have it off to the side right here. So you can see, just like before, we multiply, x times x squared, we get x cubed. We can multiply all of these, but then we have to be very careful about which ones we combine together. The x cubed is kind of on its own, but you can see we can combine the x squareds together to get our 4x squared. Again, they're not always going to be the same piece added together. Then we have our x's. So we have a 3x and a 4x. We can see that gives us 7x. And then we have a lonely number 6. So that's how we were able to, combine any terms that are like and get our following results. So let's go ahead and look at number 1 now. It wants us to draw a graphic organizer. Now, we're going to do it in the margin, but it wants us to do it for x minus 3 times x squared plus 5x plus 6. And it wants us to label each interior rectangle and find the sum. So it's essentially asking us to do what we did in the warm-up kind of up here, except now with this problem. So I want you to go ahead, see if you can kind of recreate this, but using our new values, and set it up over here. Play the video when you are ready. All right, let's go ahead and check. So I actually kept the trinomial on the left side and the binomial up at the top, similar to what we did here. But I will also tell you, I could have put the binomial off to the side, and I could have put the trinomial on top. It doesn't matter how we set it up. But we do realize we have to combine any terms that are alike. So I saw I had my x squareds and my x's that are alike. So this should be our final answer in the end. So that's exactly what we're looking for right here. Now, there's a little bit of a pattern. As we can see, since we're multiplying a 3 term by a 2 term, we know we're going to need 6 boxes because 3 times 2 is 6. So looking at number 2, it says how many boxes would we need to represent the multiplication of this polynomial times that polynomial using a graphic organizer. So let's go ahead and instead of saying to explain, we're going to kind of talk this through. So as we said before, if we have 2 terms and 3 terms, we can multiply it together to know we have 6 boxes to show what we're doing. So if we have 1, 2, 3, 4 terms times 1, 2, 3, 4, 5 terms, well, that means we're going to have 4 times 5. So we're going to have 20 boxes to represent that multiplication. Now let's look at part B. It says, would you use the graphic organizer, this box method, for other multiplications with this many terms? Explain your reasoning. Well, keep in mind, 20 terms is kind of a lot to, 20 different terms that we're combining alike together. 20 boxes is a lot. So maybe the distributive property will go a little bit faster this time. I mean, we know how to use and do both, so we're just kind of accustoming ourselves to what's really going to be the best method and what's going to be the best approach. The table's going to be kind of a little bit long and a little bit wild, right? So maybe it would be better to use distributed property. So we'll put maybe it's better to use distributive property with so many terms. So now we're actually going to apply the distributive property when utilizing different terms. So we're going to go ahead and look down here below. Now I know the arrows kind of look a little crazy in the textbook, but bear with me. I know the way I kind of draw them makes them a little bit easier, but we're going to use some color with this, okay? So it says a distributive property can be used to multiply any polynomial by another. We multiply each term in the first polynomial by each term in the second polynomial. So kind of similar to what we've done before. You know me, I like to use a little bit of color, right? Okay, so I'm going to pop up and I'm going to highlight my x in red. I'm going to highlight my -3 in blue. And I'm really showing you how, hey, we're going to make sure the x is going to be multiplied times the 5x squared. And we're also going to make sure it's multiplied times the -2x as well as the 1. Then we're going to go ahead and make sure our -3 is multiplied times 5x squared, then multiplied times a -2x, then multiplied times the 1. Now, they didn't show out all their steps of multiplying and then combining like terms. They kind of just went to the resulting answer at the end. But I definitely want to make sure you are showing your work for each of these, okay? So let's start off looking at part 3A together. So looking at this, I want to distribute this x to everything inside the parentheses. This is kind of nice because for this one, we really don't need a whole lot of color, right? We're already just showing how the x is going to be multiplied times everything, and that's it. So we're just going to have x squared plus 5x is our resulting answer. All right. Now, since we're purposely trying to not do two binomials times each other, let's go ahead and skip part B. We've done plenty of practice with that. I want you to go ahead and now try part C. So let's try this together. So I'm going to use two different colors. So I'm going to highlight my X in red, and then I'm going to highlight my 7 in blue, and I'm going to show a little bit of this. So we're going to do X times 3x squared, so that's going to be 3x cubed. Then I'm going to do x times a -x, so then that's a -x squared. Then I'm going to do x times -1, so that's -x. Then I'm going to distribute the 7 to the 3x squared. So if you can see what I'm going to do here, I'm actually going to line them up vertically so the correct terms are underneath each other. All right, so maybe that'll help you out. So when I do 7 times 3x squared, that's 21x squared. So I'm going to put a positive 21x squared underneath here. Then I'm going to do 7 times a -x, so that's -7x. Then I'm going to do 7 times a -1, so that's -7. And look at this. If we combine the terms that are alike and we work downward, we can see we get our final answer of 3x cubed plus 20x squared minus 8x minus 7. So that's one way we can approach it. Or I can also show you how maybe we don't want to, after we multiply and then add them vertically, maybe we just want to, combine the terms like horizontally, kind of like what we've done before here with binomials. So let's try that in part D. So again, I'm going to highlight my 3x first in red, then I'm going to highlight my -7 in blue and show a little bit of my math. So I'm going to, a little too thick, I'm going to do 3x times 4x squared, that's going to be 12x squared. Then I'm going to do 3x times 4x, and again, that is going to be plus 12x squared. Ooh, hold on. My first one should have been 12x cubed. Make sure you change that. All right, so we have 12x cubed, then we have a plus 12x squared, and then when I multiply 3x times a -3, that should be -9x. If I keep going with the -7 times 4x squared, we'll get -28x squared. Then we'll do -7 times 4x. That'll be a -28x. Last but not least, we're going to do -7 times a -3, and that's going to give us a positive 21. Again, a lot of the numbers are repeats here, so always be careful with what you're doing. And now I'm going to use a little bit of color to see if I can find or maybe group together any terms that are alike. So I have an x squared here and an x squared there. I also see that I have an x and an x there, so those are the terms I'm going to combine that are alike. So I'm going to start off with having 12x cubed. Then when I combine my x squareds, I should get -16x squared. When I combine my x's together, I should get negative 37x, and then I'll add my 21. So that will be my final answer here. Now we're going to go ahead and skip number 4 and head to our next page. On the next page, we are also going to skip numbers 5 and 6. So we're going to go ahead and zoom into number 7. Now, I know we're going to go a little crazy here, but number 7, it says, you can technically find the product of more than just 2 polynomials. Whoa, I know, right? So let's say we wanted to multiply these 3 binomials. I know, kind of crazy. Well, what we could do is we could first multiply, the product of our first 2 polynomials, get that result, and then take that result and multiply it by the 3rd binomial. So let's try to do that. That's what part A tells us. Okay, it says, since we have these first 2 binomials, right, let's multiply those together first and see what we get. So you go ahead, choose the distributive property, choose the box method, figure out what you get, and then play the video when you're ready. All right, you should get 2x squared plus 7x plus 3 for that. So that's the result of when we multiply the first 2 binomials. And now remember, we have to multiply that times our 3rd binomial, 3x minus 2. So now here's what we're doing. We're taking 2x squared plus 7x plus 3, and now multiplying that times 3x minus 2. So that takes our new idea of a trinomial times a binomial. Now I'm going to work this one through because I know it's a little bit more difficult. And I know most of the time when we showed the distribution property, we had our one that was 2 terms first. So I'm going to kind of walk you through how I'm going to set this up. And I'm going to use a little bit of color, all right? So I'm going to take 2x and I'm going to put it in green. And I'm going to show you how I'm able to distribute and rewrite that. So I want to multiply the 2x squared. I want to multiply both of those second terms by it. So let's go ahead and start off by multiplying 2x squared times 3x. That's 6x cubed. And then we're going to take the 2x squared and times it by the negative 2. So it's negative 4x squared. So again, that's what I get for multiplying the first ones together. All right. So now let's highlight in a different color. Let's choose yellow. So I have 7x. And now I'm going to multiply that times 3x and times negative 2. So 7x times 3x is going to be a positive 21x squared. And then I'm going to do 7x times a negative 2, so that's a negative 14x. So again, from what we've been seeing, that's how I get my middle pieces. Then let's do our last ones, all right? Let's pick red. So I'm going to highlight 3 in red. Awesome. And I'm going to distribute that 3 to the 3x and the negative 2. So 3 times 3x is going to be a positive 9x. And then 3 times a negative 2 is a negative 6. Whoa. So look at what we have. What's actually kind of nice is when we have our trinomial ahead of our binomial is, yes, we kind of have to do an extra step because we have to multiply this 3 different times. But what's nice is you can see the like terms are by each other. I can see the x squareds are by each other. I can see the x's are by each other. So it's a whole lot nicer to find that final simplified polynomial. So here we'll get 6x cubed, and then we're going to have plus, what is that, 17x squared, and then we're going to have minus 5x, and then we'll have minus 6. So take a look at that. Wow. All right. Cool. So again, I'm not going to make you practice too many of these or many more. I think practicing one of them on our own is just enough, but we can see that we can apply the same idea of multiplying different types of polynomials with each other, just as we could multiply more than just 2 polynomials with each other. Cool. All right, so that is the end of the video for Miss Graham's class. There's nothing else that you need to do. Besides tomorrow, we're gonna go ahead and practice all of these ideas that we've learned today for our upcoming assessment. So I will see you all tomorrow.